Hello and welcome back. This will be the first video on Chapter 3. So this is Section 1 of Chapter 3. This is on measures of center. And like the name implies, this is going to be a way of sort of measuring the center of a data set. So we'll talk about a bunch of different measures of center. So the first one is going to be the mean. And this is just going to be essentially the average, although this textbook does make a difference between the mean and the average. So we'll use the word mean here, but in other contexts outside of this class, this is often referred to as the average. So the mean is just going to be the sum of all data values, and we'll divide by how many data values there were. So to describe this, we'll use some notation here. An individual data value we'll often refer to as x, and we'll use a capital sigma to mean the sum of whatever it is that we are adding together. So for instance, if I write sigma x, this means that we're just going to add up all of the data values. N will be used to represent a size of a set. So for instance, a lowercase n will be looking at a sample size, so how many data values are in a sample. And capital N will be the number of data values in the entire population. So again, this is just sample size, how many things are in the sample, and a population size, how many members are there in the entire population. So when we are finding the mean, we can either find the mean of a sample or of a population, and the formula is essentially the same. We will add up all of the data values and divide by the number of data values, either little n in a sample or capital N in a population. These have different names. We use x bar to represent the mean of a sample, and we use mu, the Greek letter mu, for population. So mu kind of looks like an M crossed between a U, and x bar we'll use whenever we're referring to a particular set of values that we're referring to as x. So let's go through an example. We have a sample of quiz scores given in a class. So these are, say, taken out of 10, and we've got 5 quiz scores. So if we want to find the mean, we will take these quiz scores and we'll add them together. And we divide by how many quiz scores there are. So there are 5 here. So this is a fairly simple formula. We're just adding up a bunch of numbers and then dividing by the number of numbers. So we'll get 40 divided by 5, which happens to be 8, which seems like a reasonable center to this sample. Some of the properties of the mean: sample means vary less than other measures of center. So what this is trying to say is that if I take a sample from a population and you take a sample from a population, the mean from my sample and the mean from your sample are probably going to be pretty similar. This only applies when we're taking big samples. So if my sample size was 1 and your sample size was 1, they're probably going to be pretty different. But if I took a sample of like a big enough sample size and you took a big enough sample, the mean of our samples are probably going to be pretty close. And this does use every data value. So the formula for the mean uses each data value explicitly. We add them all up before dividing by n. However, the mean is not resistant. And so what is it not resistant to? It's not resistant to outliers. So an outlier is a data value that doesn't really match the rest of the data values. It's either going to be a lot bigger than the rest of them or a lot smaller than the rest of them. And when a measure of center is resistant, it means that outliers aren't going to affect the center very much. The mean is not resistant. So for example, if we came back to this example and I changed one of these data values to be an outlier, so say 40 as opposed to 7, 7, 8, and 8, this is going to affect the calculation of the mean quite a bit. So when we have 40 here, we'll have, so instead of the sum total being 40, we'll have 70. And when we divide this by 5, we will get 14. So the mean, which was 8, when we included this outlier, increased all the way up to 14, which maybe doesn't feel like the center of the data anymore because of this outlier. So the mean is greatly affected by outliers. One example of a way of measuring the center of data that is not affected by outliers as much is called the median. So the median is just going to be the middle value when data is arranged in order. So what do I mean by the data value, by the middle value? I think this is easiest through example. So let's say that we have an odd number of data values. So here we have the numbers 1 through 7. So there's 7 numbers here, and we can clearly identify that there is a middle data value. There are 3 numbers less than 4 and 3 numbers bigger than 4. So 4 is right in the middle. So 4 is going to be the median. Unlike the mean, which we use x bar for, the median doesn't have a usual symbol associated with it. We might just write median or med or a capital N. I will try to write out just the whole thing. So here the median is going to be 4. When there's an even number of data values, we have to work a little bit harder. So here we have the numbers 1 through 8, so there are 8 values here, and there's nothing that's right in the middle. But what we'll do is we'll take the median to be the thing halfway between the 2 numbers in the middle. So again, there are 3 numbers less than 4 and 3 numbers greater than 5. So 4 and 5 are going to be the ones right in the middle. So what we'll do is we'll take the number exactly halfway between 4 and 5. Again, the best way to calculate the middle of 2 numbers, we'll add them together and divide by 2. Looks a lot like taking the mean of those 2 numbers. In this case, this is going to be 4.5, which should match with, yes, the number exactly between 4 and 5. So again, if there's an odd number, it's the data value right in the middle. If there's an even number of data values, it's the number halfway between the 2 middle data values. So like I mentioned before, the median is resistant to outliers. So if there is an outlier, the median isn't going to change too much. So for instance, in this example, if instead of 8, I replace this by the number 100, the order of the numbers hasn't changed, and the median is still going to be halfway between 4 and 5. So it didn't even notice that there was a 100 instead of an 8 here, which maybe that's a little bit of a drawback because the median doesn't directly use every data value. Maybe we want something to notice the fact that there's a 100 instead of an 8 here, but ultimately we don't want the median to change, or we don't want the center to change too much if there's an outlier on the outside. So there are some pros and cons to using the median. The mode is another way of kind of measuring the center of data depending on the context. And this is fairly simple. It's just the data value that occurs most often, the one with the greatest frequency. So for instance, we have a few data sets here. This data set has 1, 2, 3, 3, 4, and 5 in it. And we notice, 3 appears twice. So 3 appears most often. So the mode here is 3. But in this next data set, we've got 1, 2, 3, 3, and 4, and 4. So 3 is a mode, but so is 4. So we can have multiple modes in the same data set. So we've got 3 and 4 are both modes. And we could be in a situation where no data value appears more than once. This just means that there is no mode. Depending on the precision of the instruments, say if we were measuring temperature down to the 100ths of a degree, it would be pretty unlikely that we'll get one measurement more than once. So this could happen quite often, but if we're counting groups of people, small groups of people, it will probably occur, numbers will probably occur more than once. So there's a couple nice things here. One is the mode can be found for qualitative data. So if we were asking people to describe colors, we could find a mode, meaning the color that is described most often. So it doesn't have to just be numbers to find a mode. It could be for qualitative data as well. But in that case, there is no center color. Bimodal specifically means that there are two modes. Multimodal means that there are more than two modes, and we just say that it has no modes. And specifically, this means no data value is repeated. So no data value occurs more than once. The last measure of center that we'll look at is going to be the midrange, and this is the number that's exactly halfway between the minimum and the maximum. So again, the way to calculate the number halfway between two numbers is we add them together and divide by 2. So the formula here is just going to be the minimum plus the maximum divided by 2. So let's come back to our example from before. The minimum here is going to be 7, the maximum is going to be 10, and when we find the mid-range, this will be 8.5. So here we can see that the mid-range is pretty easy to calculate. However, it is not resistant to outliers. So again, if we make that same change before, if we had a bunch of data values that are either 7 or 8, and then one outlier, the mid-range is going to change from 8.5 to something a lot bigger than 8.5. This will be 23.5 now. So the presence of outliers is really going to affect the mid-range, because outliers are really going to affect the minimum and maximum. And the mid-range is not used very much. However, it is often confused with the median. So remember that the median is the middle of the data. So the median here, since we have 5 numbers, the median is just going to be 8. So the mid-range of the original data set, which had a 10 there, the mid-range was 8.5, the median is 8, even though they are both described as sort of the middle of the data. So it is something to keep in the back of your mind. Now, rounding is important here. We need to know how many significant figures we can keep when doing these sorts of calculations. For the mode, this isn't a problem. The mode is just whichever data value occurs most often, so we can just list off the mode really easily. But for instance, when we're calculating the mid-range, we have to use this formula here. So when we calculated the mid-range here, we got 8.5, and the rule of thumb is that we want to include one more decimal place than the original data set. So all of these are integers, so we can think of these as just going to be 7, 7, 8, 8, and 10, but we want to carry on with with one more decimal place. So we'll add one more decimal place behind 8 when we're doing this calculation. If the mid-range, if after we calculated the mid-range we had some huge long decimal, we are going to round it so that, again, there is only one more decimal place than the original numbers. And we'll do the same thing for the mean, the median, and the mid-range. We are just going to carry one more decimal place. And again, this is not going to be super important, but something to keep in the back of your mind as you're doing these calculations. And the very last thing I want to mention is just think about what the data means. If you're taking the average of Jersey numbers, it isn't going to mean much. So think about when you're taking an average or a median, and make sure that it's an important data, an important, meaningful data.